Hello everyone and welcome back to Diksha Karnataka YouTube channel, and today I am bringing you the solution for mock test number 3. The question paper was shared to you in the morning, so here I am back with the answer of KPL match 3, that is mock test number 3. And if you are wondering how you can attend the test, the link is given in the description. You have to join our WhatsApp group. We will be sharing the question paper on our WhatsApp group every Sunday, and it is absolutely free. You can download the question paper, you can solve it on your own pace, and whatever topics that we are covering during that week, that topics and any extra topics that we have covered in our previous classes, if required, I will be informing you that okay, we are also adding some questions from previous week topics. So otherwise it is generally the topics that we being taught in that particular week. You have to download the question paper, you have to solve it, and at night I am back with the solution for paper number 3. So I hope you have enjoyed this question paper. This question paper was really good in my opinion. It was actually balanced question paper, some very common questions as well as some very critically thinking level questions. So let's start with the first question. Potential difference between the point P and Q in the electric circuit as shown. So very simple question that you have to find the potential difference between these 2 points. Now some of you might be wondering, okay, this is basically a Wheatstone bridge, so potential difference should be 0. Actually my dear friend, you are wrong. This is not a Wheatstone bridge. Even though it is appearing to be a Wheatstone bridge, it is appearing to be in balanced condition. Wheatstone bridge is when you are measuring the potential difference or anything around these 2 points, but here we are measuring in along P and Q, which is not the Wheatstone bridge. Wheatstone bridge is only when it is measured in the opposite way. So if the resistance is connected like this, and if we are measuring the voltage across the resistance, not across the resistance but in the diagonally opposite direction. So if we are measuring along these 2 directions, then only we can apply the principle of Wheatstone bridge and we can remove this resistance and we can calculate, etc, etc. But in this case they have not given you like this. So basically what they have given you, once I draw this diagram, redraw this diagram, then you will say, oh my god, this was a so easy question. Yes, so what we have to do, you have to redraw it like that. First we will draw P, then we will draw Q, then we will draw the resistance here, then another resistance here, then another resistance on the bottom side, another resistance on this side. So basically it's a simple combination of resistances, nothing related to Wheatstone bridge in this problem. So this is 3, then this will be 4, okay, this is 6, this will be 8. Now these 3 and 4 are in series combination, these 6 and 8 are in series combination. So 3 plus 4 is 7. So 7 is the resistance. Okay, this resistance is given 2 ohm, this will be 7 ohm. Okay, and this one will be 14 ohm, right? This one will be 14 ohm. Now if you add all these 3 resistances, then they are all in parallel. So suppose the equivalent resistance is 1 by Req, then that will be equals to 1 by 2 plus 1 by 7 plus 1 by 14, and the LCM will be 14. So it will be 7 plus 2 plus 1. So 7 plus 2 is 9, 9 plus 1 is 10, so 10 by 14. So R equivalent is 14 by 10, don't make mistakes. So it will be 1.4 ohm. So equivalent resistance is 1.4 ohm, current is given 15 amperes. So the voltage drop will be V is equal to IR, that is 15 times 1.4, that is about 21, about 210. Okay, approximately. How can I say it is 21? Because 15 times 15 You should remember that 15 times 15 is what? 225, right? So what will be the value if it is instead of 15, if it is 14? Okay, if it is 14, it should be around 220, 210, right? So it will be around more than 200 obviously, but it will be very close to 225. So based on the options, I can guess it will be 210. Now there is a point here, so it will be shifted here. So 21 should be the answer, right? So you have to be smart while calculating this kind of equations, right? As I told you, practice without using calculators so that your calculations, your approach becomes better and you are well equipped when it comes to your whatever competitive examination you are trying. If you are practicing without calculator, you will be very good when the final time comes. Now the resultant resistance value of n resistances, each of R ohm, when connected in parallel is X. When these n resistances are connected in series, the resultant value is. So what is the meaning of that? We have n resistances, each of them are connected in parallel. Okay, each of them have value R, and that when they are connected in parallel, so parallel I am writing like this, parallel combination, parallel. For parallel combination, we know that when all of them are equal resistances, the equivalent resistance becomes R by N. I told you multiple times, when n number of resistances connected in parallel, each having same resistance, then the equivalent resistance becomes R by N. Now this is given as X. Okay, this value is given as X, right? So R equals to Nx, right? So we have calculated the value of R. Now when they are connected in series, then what will happen? The equivalent resistance becomes N times R. The equivalent resistance becomes N times R. For series it is NR, for parallel it is R by N, right? So it will be N times Nx, that is N square X. So this is the equivalent resistance when they are connected in series. So correct answer is option B. Okay, now this is also a very interesting question, very intelligent question. I won't say this is a very dumb question. This is a very intelligent question. Now they have asked you, they have given this diagram and they have asked you find the equivalent resistance between the point A and between the point B. Now based on the combination whatever they have given you, this value will change, right? So in this case they have given you find the equivalent resistance between A and B. So what is the path a current can possibly follow while flowing in this circuit? So first of all, the current can flow from here and come back here, right? So this is one path. Another path is current can flow here, through here and then come back. Okay, this is also another possible path. Okay, now based on the resistances they will divide itself and they will follow. Now no current can flow here, and then current will, where it will go? It will hang. So similarly no current can come back from this side D. So you have to think and you have to imagine through which current can pass. Possibly current can pass. If the current is not able to pass that resistances, then they are just useless. So basically the meaning of that is this resistance and this resistance are useless. No current is passing through these two resistors, okay, because we are calculating the equivalent resistance between A and B. If it was A and C only, I am giving you one more example. If it is only A and C, no current possibly could have passed between this B section and D section. Current can directly go in this direction or current could have passed in this direction. Okay, so only this part we need to cover, and you can ignore these resistances and that resistance if we are considering A and C. So based on what combination they have given, you have to consider which all are the correct possibility. Now, so now you can see that this resistance and this resistance, these three resistances you can draw using without lifting your pen. So when you can draw resistances without lifting your pen, that means they are connected in series, right? So they are connected in series. So 2 ohm, 2 ohm, 2 ohm, 3 2 ohms are connected in series. So the equivalent resistance will be 2 plus 2 plus 2, that is 6 ohm. Okay, Now, so what will be the value? A. Okay, now this is 6 ohm, this is 3 ohm, this is 3 ohm, this is 3 ohm. Okay, now 3 ohm and 6 ohm are connected in parallel. So what is the equivalent resistance for this section? For this section, the equivalent resistance will be 3 times 6 divided by 3 plus 6. Only two resistances are there. So for two resistances, we will simply use this formula. So 18 by 9. So it will be 2 ohm. Okay, so now final circuit becomes 3, 3, 2. Okay, so 3, 2, 3, all of them are connected in series. So the equivalent resistance will be 3 plus 3 plus 2, that is 8 ohm. Okay, so the correct option is option A. Very simple question. Now tell me in the comment box, have you ever able to find out or figure out this question, if you have answered it correctly or not. Now question number 4. Three resistances 2 ohm, 3 ohm and 4 ohm are connected in parallel. The ratio of the current passing through them when their potential difference is applied across the ends will be. So three resistances, okay, one 2 ohm, one 3 ohm and another one is 4 ohm. They are connected in parallel. Okay, and now we have applied a potential difference. Now what is the common thing in parallel combination? In parallel combination, only one common thing is that potential difference across each of them are same, right? In case of series combination, current through each of them are same, but in parallel combination only potential is the same, current different, right? So suppose the current through this is I1, this is 2, this is 3, this is 4. Current through this is I2 and current through this is I3. Now potential difference across each of them are same. So what we can write? We can write I1 times 2 equals to I2 times 3 equals to I3 times 4 equals to the potential difference that we have applied, right? So I1 becomes basically V by 2, I2 becomes V by 3 and I3 becomes V by 4. So now they have asked you what is the ratio. So I1 is to I2 is to I3 is V by 2 is to V by 3 is to V by 4. Now V will be cancelled, and what is the LCM of 2, 3 and 4? 2, 3 and 4, the LCM is 12. So multiply everything with 12. So 12 times 1 by 2. I am doing it little bit detailed so that you don't get confused in mathematics. Okay, if you can solve it in one line, that is fine. So it will be 6 is to 4 is to 3. So 6 is to 4 is to 3 is the correct answer. Okay, so this is the correct answer. Don't get confused, don't mark in anything other order. Okay, now this is also a very interesting question. Okay, I think this is a very tricky question but a very interesting question. Mention that in the comment, have you ever able to answer this question correctly or not once I complete the solution. Find the effective resistance between A and B in this circuit. So they have given you this circuit A and B. Now you might think only R and R is parallel, so the equivalent resistance will be R by 2. But if you see, there is no option given as R by 2. If I was the question paper setter, I would have given option R by 2. It was already a very popular question, so I have not changed the question as it is. So I have not given you that option R by 2. Someone who framed this question must have thought that okay, R by 2 students will be confused, so they have not given it. But what is the catch is that if you see, these two resistances are connected to the ground. Both of them are connected to a common potential. I will not say ground, they are connected to a common potential. So what is the meaning of that? You can extend this line and you can consider them are connected like this. Okay, so they are connected like this, zero potential, right? So we can consider them as connected internally through this channel, right? So now if I draw this diagram, then this will become right. So this arrangement will become like this. So they are connected, these R and these R are basically connected in series, right? Now if these two R's are connected in series, and then this combination will be connected in parallel, right? So R plus R is 2R. So simply I can write this as 2R. Now the equivalent resistance 1 by R plus 1 by R plus 1 by 2R. So the LCM is 2R. Okay, 2 plus 2 plus 1. So it will be 5 divided by 2R. So equivalent resistance will be 2R by 5. So this is the answer, 2R by 5. So correct answer is option B. Okay, now another interesting question, the variation of resistance of the conductor with temperature is as shown. Temperature coefficient alpha of the conductor is. Now we know that temperature coefficient alpha, I have already given you this formula, is R minus R naught divided by delta T times R naught, right? This is the formula. Now if you see in this diagram, in this formula, I can write R minus R naught as delta R and delta T into R naught, right? Now what is this? Delta R by delta T. So if you see in this graph, this is basically signifies delta R and this signifies delta T. So delta T means delta X, delta R means delta Y, right? That is the formula for a straight line, right? Now we know that slope is given by delta Y by delta X, right? That is in this case delta R by delta T. Okay, so you just need to put delta R by delta T means M, so it will be M divided by R naught. So alpha is M divided by R naught. Okay, so correct answer is option C. Very simple question, very trick question. If you have understand the concept of what is alpha, then only you will be able to answer this question, right? Now next question, the quantity of charge that will be transferred by a current flow of 20 ampere over 1 hour 30-minute period. Very straightforward question. Okay, I is equal to Q by T. They have asked you to find Q for I 20 ampere and time is 1 hour 30 minutes. 1 hour 30 minutes means 90 minutes. 90 minutes means 90 times 60 seconds. Okay, you have to convert it into the units. That's it. Rest is easy. Now multiply. It will be 12 times 9 times 10 to the power of 1, 2, 3 zeros. Okay, now it will be 90 plus 18, so 108 times 10 to the power of 3. Okay, so if you see the answers, they have given in decimals. So let me find one of the correct decimals. So 10, so these two can be possible answers because we do not get 1.8, we do not get 5.4. So 10.8 times 10 to the power of 4, right? So if we put one decimal, we have to add the 10 to the power by 1. So correct answer is option number D. Okay, simple question. So only thing that you have to solve it and then rearrange the 10 to the powers, right? Next, question number 8. A cell which produces an EMF of 1.5 volt is connected in series with an external resistance of 10 ohms. If the potential difference across the cell is 1.2 volt, the internal resistance of the cell is. So very interesting question. So we know that V is equal to epsilon minus IR. That one thing. Also V is equals to I times external resistance. That is also true, right? Because that's how we calculated V. Now V is given as 1.25 volt. Epsilon is given as 1.5 volt, they have asked you to calculate small r. So first we will calculate the current. If we can calculate the current, then using this formula we can calculate small r. So V is given as 1.25, I we don't know, resistance is given 10 ohms. 10 ohms, so I is basically 1.25 divided by 10 or 0.125. This is the current. Now again we are using this formula, 1.25 is equal to 1.5 minus I is 0.125 times R. So it will come in this side, 0.125 R is equal to 1.5 minus 1.25. Okay, so it will be 0.25. So R will be equals to 0.25 divided by 0.125. So let's remove the decimals. It will be 250 divided by 125. So if you cancel, it will be 2 ohm. Okay, so the correct answer is obviously 2 ohm. Okay, you need to improve your analytical ability, need to improve your calculations, need to improve how faster you can calculate these kind of equations, right? Now in the circuit given here, the galvanometer G reads 0. So galvanometer G reads 0, so no current is flowing through this. So galvanometer basically detects the presence of current. If no current passing through this, then it will read 0. So current through this circuit is 0. Now when this can happen, this is actually a trick question. This is a true question where you have to understand the concept, then only you will be able to answer this question. Now if you consider no current passing through this galvanometer, that means the potential at point B and potential at point C must be equal. So VB must be equals to VC, right? Or in the other way, we can say potential across R should be potential across CD. Okay, so potential across R should be potential across CD. So how we can do that? So potential across R, CD, we know it is given 2 volt. The same potential should be across the resistance R as well. Now no current is flowing through this, only current flowing is in this direction. Okay, so now what is the current in this current? What is this current? This current I should be equals to this voltage 6 volt divided by total resistance 10 plus R. Okay, this should be the total resistance. Now what is the voltage drop across a resistance? Voltage drop across one resistance is given by IR, right? So this is the voltage drop across B and E. So VBE. Now as we have deduced, since no current flowing in this direction, this VBE should be VCD, that is 2 volt. So IR should be equals to 2 volt. Okay, now put the value of I here, 6 times R divided by 10 plus R equals to 2. Okay, now cross multiply, 6R equals to 20 plus 2R, okay, or 4R equals to 20, or R equals to 5 ohm. Simple as that. So only thing is important in this case, you need to understand that when galvanometer shows no deflection, that means zero current is flowing. Zero current is only possible when potential difference is 0. That means potential across this should be equals to potential across this. That is the only possible way when no current can pass through G. Okay, now calculate the current I in the circuit. Another simple question. So they have given you this current 2A, okay, and they have asked you to find the current in the outer circuit. Okay, so what you have to do? You have to find the current in this branch. Okay, if you can find the current in this branch, then you just need to add these two current, because Kirchhoff's junction rule says that total current should be total incoming current should be total outgoing current. So here incoming current is I, outgoing current is 2, and this current, this unknown current I that we don't know, say I1. So we have to do find I1. Now what is other thing is given, that these two resistances are connected in parallel. Now in parallel combination, voltage remains constant. So whatever voltage drop across this resistance, the same voltage drop should be across this resistance as well. Now what is the voltage drop across this resistance? Voltage drop across resistance 3 is given by current through this 2 ampere into resistance of this 6 volt. 6 volt is the voltage drop across this resistance. The same voltage drop should be across this resistance. So V6 should also be equals to V3 because they are connected in parallel. So it will be 6. Now what is this I1? We are interested to find this I1 times 6. This 6. This 6 is this 6, right? So times 6 is equals to 6. So I1 is equals to 1 ampere. So I1 is 1 ampere, this is 2 ampere, so I should be 2 plus 1, that is equals to 3 amperes. Okay, so 3 amperes is the correct option. Simple problem. Do not waste too much time in this kind of problems. You have to understand the concept and apply it quickly and solve it. In the electric circuit shown, each cell has an EMF of 2 volt and the internal resistance of 1 ohm. The external resistance is 2 ohm, the value of the current in this circuit. So very simple question. They have applied how many batteries are there? I think I have solved this question during one of my lectures. So see, this battery is forward in this direction, sending current in this direction. Okay, whereas this battery is also in the forward direction. So these two batteries are sending current in this direction, whereas this battery is sending current in this direction. So this is connected in opposite polarity, right? So what is the effective polarity? Effective polarity is potential difference is 2 plus 2 minus 2. So it is only 2 volt. So 2 volt is the actual voltage, but in case of internal resistances always added. So total internal resistance will be 1 plus 1 plus 1, that is 3 ohm. Okay, so basically you can redraw this circuit as one external resistance of 2 ohm and one battery of 2 volt and one internal resistance of 3 ohm. Okay, now what is the total resistance? Total resistance is 5. Total resistance is 5. 2 plus 3. So current will be 2 divided by 5, that is 0.4 ampere. Okay, so 0.4 ampere is the correct answer. Simple problem. Keep it simple, understand it and solve it quickly. Now 5 resistances are connected as shown in the figure. The equivalent resistance between A and B. So equivalent resistance between A and B. I hope this image is clear to you. Now this is a case where you can apply Wheatstone bridge, not in the first problem. Here if you see, 2 by 4 is half, right? 2 by 4 and here it is 3 by 6. Both of them are equals to half. So Wheatstone bridge condition is satisfied and we are finding the equivalent resistance between these 2 points. So we can apply Wheatstone bridge principle and we can remove this resistance. Okay, this resistance is no longer functioning because this is Wheatstone bridge balance condition is satisfied, so no current will pass through this, so we can simply ignore this resistance. So what is the circuit? Circuit is simple. Okay, 2 ohm, 3 ohm in series, 4 ohm and 6 ohm in series, and they are connected in parallel. So it is 5 ohm and 10 ohm. They are connected in parallel. 5 and 10 connected in parallel. So equivalent resistance is 5 times 10 divided by 5 plus 10. So 50 divided by 15. Okay, so it will be 10 divided by 3. So 10 by 3 is the answer. Okay, 10 by 3 ohm is the answer. Simple problem, not a difficult problem. This one I think most of you have corrected. If you have not able to understand this concept, mention that in the comment below as well. Now, the potential difference between the terminals of a cell in open circuit is 2.2 volts. Similar problem, this is also similar problem that we have solved before. With the resistance of 5 ohms across the terminals of the cell, the terminal potential difference is 1.8 volt, the internal resistance of the cell. So we have already solved one problem. First, what we will do, we will V is given 1.8 volt. Okay, epsilon is given 2.2 volt. Now, what we will do, first we will calculate the current in terms of external resistance. So external resistance is 5, so it should be equals to 1.8. So I is equals to 1.8 divided by 5, so it will be 0.36. okay, and we know that V equals to epsilon minus IR. Okay, so 1.8 is equals to 2.2 minus 0.36 R. Okay, so 0.36 R equals to 2.2 minus 1.8 equals to 0.4. Okay, so R is basically 0.4 divided by 0.36. So it will be, if you multiply, it will be 40 by 36. If you remove the decimals, it will be 40 by 36. So 4 tens are 40, 4 nines are 36. It will be 10 by 9. Okay, so 10 by 9 ohm is the correct answer. Now, here it is said that a 5 ampere current is set up in an external circuit by 6 volt storage battery for 6 minutes. The chemical energy of the battery is reduced by, we know that energy basically means the energy spent by the battery. So that is basically vitamin. Vitamin gives you energy. So remember that vitamin gives you energy. So I told you while teaching the class. Okay, so vitamin is the formula. So vitamin V is 6 volt, I is 5 volt, T is 6 minutes. 6 minutes means 6 times 60 seconds. Only one unit that you have to convert. Now 5 6 are 30. 30 times 6 6 36, 360. Okay, so 360 times 3 times 36 is 108, and there should be 2 zeros, right? So 3 times 36 is 108 and 0 0, right? Now, so if you see, only thing, also the unit should be in joules. Volt is not an unit of energy. Okay, joules is the unit of energy. Now, you have to write it in terms of decimals. So 1.08 times 10 to the power of 4 joules. 1 2 3 4. So 4 you are putting the decimal here, so it will be 10 to the power of 4. So 1.08 times 10 to the power, sorry, not option B, my mistake, option A. Okay, so correct answer is option A, 108 times 10 to the power of 4 joules, right? Now, a battery consists of variable number of n, variable number is also given n, of identical cells, each having an internal resistance R connected in series. The terminals of the battery are short circuited. A graph of current I in the circuit versus number of cells will be as shown in the figure. Now, what is this given? That battery means it's basically a combination of cells. Some n number of cells are connected, okay, and then they are short circuited. Short circuited means they are all connected. Now they have asked you what will be the current in this circuit, current versus number. Okay, so number is given n number of cells are connected. Now let us find the total resistance, total EMF first. Total EMF will be, they are all connected in series, so n times V. Suppose V is the potential of 1, suppose V is potential of 1, okay, then total potential will be n times V. What is the equivalent resistance? Equivalent resistance will be equals to n times R, right? So n times V times n times R. Now what is the current? Current is voltage divided by the resistance. No external resistance is connected, so we can see this is actually V by R. So it is basically no matter you connect one battery or you can connect 10 batteries, you will always get the voltage as V by R. So it is independent of number of batteries. At least one battery should be connected. So only at least one battery should be connected, that is 1, and the current after that is constant. So there should be no value for 0n obviously. As long as one battery is connected, this is 1. So this current is constant. So correct option is option A. It is neither increasing nor decreasing nor dependent on square or not dependent on inverse square. Okay, so basically this is the formula. So V by R, current is constant no matter how many batteries you connect. You connect 100 batteries, it will be still V by R. You connect 1000 batteries, no matter how many number of N you connect, as long as one battery is connected, you will get the same current, right? Sorry, one cell is connected, you will get the same current. Now question number 16, a solenoid 1.5 meter long and 0.4 centimeter in diameter possesses 10 turns per centimeter in length. The current 5 ampere flows through it. The magnetic field on the axis of the solenoid is. So we know that a magnetic field inside a solenoid. Now we have first 15 questions were based from current electricity. The next 15 questions will be based on moving charges and magnetism. So B is basically given by what? Mu naught Ni, right? Mu naught Ni is the magnetic field on the axis of a solenoid. Now N is number of turns per unit length. Number of turns per unit length, even though here it is given as 10 per centimeter. Now centimeter is not the unit, so what we have to do, we have to convert it into meters. Because it is in division, so we have to divide it by 10 to the power of minus 2. So by meter, so it will be 10 times 10 to the power of 2 per meter. So basically it is 1000 per meter. Okay, so 1000 per meter. N is given mu naught. We know that mu naught by 4 pi. Mu naught by 4 pi is 10 to the power of minus 7. I told you multiple times. So mu naught is 4 pi times 10 to the power of minus 7. N is 1000 and I is given by 5 ampere. Okay, and these information are basically to confuse you. These are not required to solve this problem. They are only extra information. Okay, so it will be 5 4s are 20 pi and 1000 means 10 to the power of 3. So we can reduce it to 10 to the power of by 10 to the power of 3. So it will be 10 to the power of minus 4. Okay, now if you see none of them has 20, so what we have to do, you have to reduce it further. So this 0 will also come here and it will become 10 to the power of minus 3. So what is the unit? 2 pi 10 to the power of minus 3. So correct answer is option C. Okay, simple problem. Only one formula is required, so simple problem. A circular coil of 1 turn carrying a current produces a magnetic field B naught at its center. The coil is now rewounded so that it has 3 turns and the same current is passed through it. The new magnetic field at the center will be. So now we know that magnetic field at the center of a coil is basically inversely proportional to the radius. If you remember the formula that we have done for on the axis of the coil and on the what else we have also done on the center. Okay, so that formula was mu naught r square divided by 2 r square plus x square to the power 3 by 2. Now at the center we need to put x equals to 0, so it will come out to be 1 by r. Now also here it is for only single turn. Okay, if we have n number of turns, then it would be dependent on number of turns as well, right? Now what is happening is that initially the wire was only single turn. Okay, and suppose the radius at this case was r. Okay, radius was in this case r. Now what happened is you wound that wire to 3 turns. Okay, so now the radius is small r. Okay, so initially what was the perimeter? Initially perimeter was 2 pi r. What is the final perimeter of one round? One round is 2 pi small r, but we have wounded it 3 times, so 3 times 2 pi r. So the relationship between capital R and small r is simple. Capital R is 3 times small r. Very simple relation. Right now, initially what was the magnetic field? Say magnetic field B naught proportional to 1 by r. Okay, now what is the final magnetic field? Final magnetic field is basically BF, it proportional to n by small r. Okay, so BF will be equals to proportional to n is 3, r is r by 3. Okay, so it will be B final will be equals to 9 by r, right? So if you divide it BO by BF, okay, it will be 1 by r divided by 9 by r. Other is constant, so it will cut. So BF is 9 BO. Okay, so 9 BO is the answer. Simple, cross multiply, BF will go up, 9 will come out, 1 by r will cancel, right? Now, this is another interesting question. Conducting wire carrying current is arranged as shown. The magnetic field at O is. So magnetic field at O, we already told you the formula. What was the formula? In our previous problem, I told you the formula. B is equals to mu naught r square divided by 2 r square plus x square. Now since it is due to a full circle, so this formula is basically for a full circle. So if the circle was full, okay, then this formula is applicable. Now for a full circle, what is the angle? For a full circle, total angle is 360 degrees, right? So for a full circle, the angle is 360 degrees. Now for 60 degree angle, what will be the force? This force also x should be equals to 0. X is 0 and this should be 60 by 360. Okay, for 360 degrees this is the magnetic field. For 60 degrees only it will be 60 by 360. Okay, so basically it is 1/6. So we just need to simplify it. Okay, so mu naught by 2r. Okay, so we have already done this process while during the theory class. If you don't know how we are getting it, you can check that. So we can write this mu naught by 12r. This is due to only one wire. Okay, this is only due to one wire. Okay, now what will be the direction if you consider, suppose this wire. Okay, for this wire the direction will be, current is flowing in this direction, right? So magnetic field will be, current is flowing in this direction, so magnetic field will be into the paper. So for this it will be into the paper. Okay, that is circle. Now for this, the current is flowing in this direction, so the magnetic field will be out of the paper. So for R1 it is into the paper, for R2 it is out of the paper. Okay, I told you how we can find the direction of magnetic field if this is a straight wire carrying current. Okay, and the magnetic field lines will be circular in nature. If the current is flowing along your direction of your thumb, then your fingers will point towards the magnetic field. Remember that the magnetic field due to a straight wire, if you are finding the direction using your thumb, then your fingers point the direction of magnetic field. So in this case, even though it is a curved line, you can still use that same concept. The curved line is going in this direction, so the magnetic field will be into the paper, whereas in this case current is going up, so magnetic field lines will be out of the paper. Okay, so basically they are in the opposite direction. So which one is greater? Obviously R1 is smaller, so R1 will be greater. R2 is bigger, so 1 by R2 will be smaller, right? So first the magnetic field will be mu naught by 12 will be common. Obviously mu naught also, there was one I also, sorry, I mistaken that, there was one I also. Okay, mu naught I by 12 will be common, and it will be 1 by R1 minus 1 by R2. because they are in opposite direction and R1 is greater than R2. So the correct answer is this, mu naught by 12, 1 by R1 minus 1 by R2. If a velocity has both perpendicular and parallel components while moving through a magnetic field, what is the path followed by a charged particle? I told you, if there is a parallel component, then it will move in a helical motion, right? It will move in a helical motion. So the path will be helical. Okay. A particle of charge E and mass m moves with the velocity v in a magnetic field B applied perpendicular to the motion of the particle. The radius of its path in the field is, you can remember the formula or you can find it, mv square by r, okay, equals to the magnetic force Q VB. That is, in this case, instead of Q they have given you E, so EBV, right? So what is the R? R is mv square divided by EVB, right? So this R will go up, this will come down, so cross multiplication, 1V will cancel, so it will be m by EB. This is the radius of the path, right? So m by mv, there is one v still here, right? So mv by be. So this is the correct answer. Okay. Now a straight current carrying conductor is kept along the axis of a loop of carrying current. The force exerted by the loop on the straight conductor. So there is a loop. I explained this during our regular lecture. I solved this problem. Okay, so if there is a current carrying wire along the axis, if you rotate this, symmetry does not change. If symmetry does not change, then that must means that there is no work done. Okay, and there should be no force exerted on this loop. So force exerted on the loop will be 0. A charged particle with a velocity 2 times 10 to the power of 3 meter per second passes undeflected through electric field and magnetic field in mutually perpendicular direction. The magnetic field is 1.5 Tesla. The magnitude of the electric field will be. So what is the question? The magnetic, it does not experience any force, right? So that means the electric force and magnetic force, they are acting such a way that they are cancelling each other. We know that magnetic force and electric force may not be in the same line, okay, because magnetic force is V cross B, so it is a cross product of V cross B, whereas we can adjust the direction of electric field such that V cross B's direction is actually opposite to the direction of E. So basically that means that scalar wise E QE should be equals to QVB. Okay, now what is the given thing? It is said QQ should cancel. Obviously they have asked you to find the electric field, and V is given by 2 times 10 to the power of 3 meter per second, passes undeflected through an electric field and magnetic field mutually perpendicular. So mutually perpendicular direction, if electric and magnetic field are mutually perpendicular direction, then this is the condition, only then it can happen, and magnetic field is given by 1.5. So it will be 3 times 10 to the power of 3. Okay, so this is the correct answer, 3 times 10 to the power of 3 Newton per Coulomb. Simple problem. Okay, QE is equal to QVB. Only in that case the force acting on the charge will be 0. Also sometimes this is called velocity selector. You should remember that velocity selector used to be in your syllabus as velocity selector, but that is no longer part of your syllabus. But this concept can still come as like this. Okay, A and B are two infinitely long straight parallel conductor. C is another straight conductor of length 1 meter kept parallel to A and B as shown in the figure. Then the force experienced by C is. So what they have asked you to find the force experienced by C. Now due to this wire, it will experience as a force. I already told you current flowing in the same direction, they experience repulsive force. Repulsive force means away from it. So force due to A on C is in this direction. Now force on C due to A, right? Force on C due to A, force on C due to B. Okay, so one force should be on this direction, another force should be in this opposite direction, and once we calculated the force, only thing we need to do, we need to subtract one from another. So first let us start with force CA. Force CA is equals to mu naught by right, this is the formula. Mu naught by 4 pi is 10 to the power of minus 7. Also there was one more important information. There was should be one L here, but L is given as 1 meter, right? So you can simply apply 1 meter to IA, in this case FCA, right? So we have to write this accordingly. IC IA. Okay, IC is 3 ampere, IA is 2 ampere, L is 1 meter divided by the distance is 5 centimeter. But as I told you, we have to convert it into meter, and the easier way to convert it into meter, especially when you are confused how many decimals will be there, so write it as 10 to the power of minus 2. Always take help from 10 to the power. Okay, now so this will become 10 to the power of minus 7 plus this will go up plus 2, and 2 3s are 6, 6 2s are 12, 12 divided by 5. Okay, so it will be 2.4 times 10 to the power of minus 5. Okay, now this is the force on FCA. Now let's calculate the same way. Let us calculate FCB. What will be the value? 10 to the power of minus 7 times 2. 2 is coming from the formula. Okay, IC is 3 times IB is 4 divided by the distance is now 8 centimeter. So it will come up 10 to the power of minus 5 as usual times 2 3s are 6, 6 4s are 24 by 8, 3 times 10 to the power of 5. Now which one is greater? So B is greater, so FCB will be greater. So the resultant force will be acting towards A. You should remember that resultant force should be acting towards A because this is a repulsive force. Now what is the magnitude of the force? Magnitude of the force is 3 times 10 to the power of minus 5 minus 2.4 into 10 to the power of minus 5, that is 0.6 times 10 to the power of minus 5. Okay, so 0.6 times 10 to the power of minus 5 acting towards A. So towards A, 0.6 10 to the power minus 5. So be careful while answering this question. Now 24, a proton with energy of 2 MeV enters a uniform magnetic field of 2.5 Tesla. Normally the magnetic force on the proton is slightly longer question. So we know that energy is basically half mv square. Energy is half mv square and it is given as 2 MeV. 2 MeV, now 1 MeV is also given 1.6 times 10 to the power of minus 13 joules. Okay, so you have to put these values back to back and calculate V. We know that force is given by QVB. Okay, QVB, we know that. So only thing that we have to calculate, if you can calculate V, Q we know for a proton is equals to an electron, only positive magnitude. So V square is basically will be equals to, this 2 will go up 4 by m. So what is the m? Value of m is given 1.67 into 10 to the power of minus 7. It is intentionally given. You have to approximate it to 1.6 so that we can simply cancel it. Okay, so 1.6 you are trying to find as close as possible. You don't need to find the exact value. So 4 times 10 to the power of minus 27 will go up and it will become positive. So 27 minus 13. So you will get 4 times 10 to the power of 14. Now take the square root of that. Square root of that will be 2 times 10 to the power of 7. Right? So velocity you have calculated. Now you put the value here. Q instead of Q it will be E VB. So E is 1.6 times 10 to the power of minus 19. V is 2 times 10 to the power of 7 and B is given as 2.5. Okay, so it will be 1.6 times 2 times 2.5 is 5, 10 to the power of minus 19 plus 7 minus 12. Now 5 times 1.6, 16 times 5 is 80. So 1.6 times 5 will be 8. Okay, so 8 times 10 to the power of minus 12 Newton. So this is the answer, right? Next, move on. 25. In a region there exist both uniform electric field E and magnetic field B. An electric charge moving in this region experiences no forces. That means what? So I already told you E should be equals to V cross B. If you are writing in vectorially, this should be the option, and if you are writing scalar, then E is equal to QVV, QE is equal to QVV, Q cancels. So this is the option. So E is equal to V cross B. Now question number 26. A circular coil of radius 10 centimeter and 100 turns carries a current 1 ampere. What is the magnetic moment of the coil? Very simple question. A coil of, what is the radius of the coil? 10 centimeter. Okay, and the number of turns is given by 100. Okay, we know that magnetic moment is basically National Investigative Agency. Okay, number of turns is 100. Current is given 1 ampere and area is pi r square. Okay, now here remember that the radius is given in terms of centimeter. Okay, so pi r square. So when you are inserting the value, you have to use 10 to the power minus 2 and then you have to whole square it. Now 10 times 10 to the power of minus 2 is 10 to the power of minus 1, right? 10 times 10 to the power minus 2 is 10 to the power minus 1. So it will be 100 times 1 times pi times 10 to the power of minus 1 whole square should be 10 to the power of minus 2. Right? So 100 and 10 to the power of minus 2 will cancel. So the remaining answer will be pi, that is 3.142. Okay, so 3.142 ampere meter square is the magnetic moment. Okay, all the formulas are simple. Now, what is the value of shunt resistance required to convert a galvanometer of resistance 100 ohm into an ammeter of range 1 ampere given the full scale deflection of the galvanometer is 5 ampere? So what is the meaning of that? We have a galvanometer, we have a shunt resistance, galvanometer resistance G. Now current through the galvanometer is Ig, current through the shunt is Is, and total external current is I. Now we know that Ig is I times shunt resistance divided by G plus S, right? We already learned this formula. Now I is given 1 ampere, okay, and Ig is given 5 milliampere. 5 milliampere means 5 times 10 to the power of minus 3. Okay, so I is 1 ampere, S we do not know. Okay, G is given 100 ohm, sorry, it will be plus S. Okay, now let's calculate. So S equals to, this will come this side, 500 times 10 to the power of minus 3 times 100 plus 5 times 10 to the power of minus 3 times S. Now S is shunt resistance, it is a very low value resistance. Also if you see, this is also very low value. So in all together we can say this has a very low value, and approximately we can say that S is very approximately equals to 5 times 10 to the power of minus 3 times 100, that is S is basically 5 times 10 to the power of minus 1, or it is 0.5 ohm, right? So it will be 0.5 ohm. This is the correct answer. Okay, you have to ignore this term, because as you see 0.5 times 5 times 10 to the power minus 3 will be 0.00005. So that much we can ignore, and that will give us the correct value, right? Now, if only 2% of the main current is to be passed through the galvanometer of the resistance G, the resistance of the shunt should be. So again, same formula, Ig is I times S by S plus G. Now current Ig is 2% of that. 2% means Ig by I, 2%. 2% means when you have to convert it back, you have to use divided by 100. That should be equals to S by S plus G. Now multiply, cross multiply. So 2S plus 2G equals to 100S, or 2G equals to 98S, or S equals to 2G divided by 98, or it should be equals to G by 49, right? So 2 and 98 will cancel, it will give you 49. So G by 49 is the correct answer. Simple problem. Now, a galvanometer of coil has resistance 50 ohm and the meter shows full scale deflection for a current of 5 milliampere. So Ig is given 5 milliampere. The galvanometer is converted into a voltmeter of the range 0 to 2 volt by connecting how much should be the resistance in series, right? Now, so 0 to 20 volt means when the maximum voltage is there, then the current should be 5 milliampere, right? So as we know that galvanometer is connected in parallel, so in that case voltmeter is connected in parallel. So in that case, what we have to do, whatever resistance that we are adding, and the maximum, when the voltage across this is maximum 20 volt, then the current should also be maximum. That should how this work, right? So voltage is 20 volt, current is 5 milliampere. Then what is the resistance? V equals to IR, Ohm's law formula. So R is equal to V by I. So 20 divided by 5 milliampere. 5 milliampere means 5 times 10 to the power of minus 3 ampere. So you have to do that, 5 times 10 to the power of minus 3 ampere. So it will be 4. So it will be 4000. Now out of this R, already G is included, right? So suppose this is R external, I am saying. So R is basically G plus R external. So G is already included, G is 50. So 50 plus 50, right? Yeah, 50. 50 plus R external is 4000. So R external will be 3950. So 3950 in series. Always remember, whenever you are converting a galvanometer into a voltmeter, the external resistance should be connected in series, and whenever you are connecting you are converting a voltmeter galvanometer into an ammeter, then the shunt resistance, which is a very low resistance, should be connected in parallel. Okay, this is very common. Now a magnetic moment 50 I ampere meter square is placed along the x-axis in a magnetic field B equals to 5 I cap plus 3 j cap. The torque acting on the magnet is, torque is magnetic moment cross magnetic field, right? Now also we know that while cross product I cross I equals to J cross J equals to K cross, just to remind you, okay, K cross K is equals to 0. And for any other combination I, J, K, if we are going in this direction, okay, then I cross J is K, K cross I is J, okay, and K cross J is I when we are going in this direction, in this order, okay. If we are going in the opposite order, then it will be minus of that, right? Now what is here, M is I cap. So I cap times I cap will be 0. So we don't need to consider this term. That's why I am telling you. This is a shortcut way. Okay, so we don't need to consider. Now, M is first, so I is first. I times j cap should be k cap, right? I j times j cap, I cap times j cap should be k cap. So, only thing we need to multiply is this 3 and this 50. Okay, so torque will be 50 times 3, that is 150, and k cap. Okay, so it is 150 k cap Newton meter. Simple. Okay, so we have completed all the 30 questions very quickly, and I hope that you are able to solve most of the questions, and mention in the comment below how many of you have answered it incorrectly, or how many of you how many of the questions you have answered incorrectly, how many of the questions you have answered correctly. Okay, see you in the tomorrow's lecture. Tomorrow we will be doing previous year question paper for magnetic moment, magnetic moving charges and magnetism chapter. Okay, so that part is pending. So tomorrow I will be covering moving charges and magnetism previous year question. Thank you. See you tomorrow.